Welcome. My name is, as Martin mentioned, Piotr Gołębiewski, but you're more likely to know me by my nickname, which is Iolio. And I'm working as a Scala consultant for Scala C, and I'm also contributing to the ZIO library. And recently I have moved to Ireland. So if you're from Dublin or the area around, hi. I'd love to meet you after the lockdown, of course. And so if you'd like to show me your favorite cafe or pub, you will find my contact details on the last slide. So I'm very excited about Scala 3. And today I will share with you why you should be excited too. But first, I wanted to thank my company and the organizers for the opportunity to speak here. So thank you, everyone involved. And now, so we will start with a quick overview of Scala 3 features, and then we will jump straight into the code, where I will show you a side-by-side comparison, how the same problem could be solved using Scala 2 and Scala 3. And finally, I will summarize how I think these changes will affect the future of programming in Scala. So, after almost a decade of work, Scala 3 is packed with features. Some of them are completely new, while some of them were already present in Scala 2 ecosystem, but were implemented using implicits or macros. And this introduced additional complexity and made it harder to use and understand by regular developers. So what are these new features? So first of all, there are many new types, and each of these is designed to solve a specific use case. For example, type lambdas. With them, it's now possible to partially apply higher candidate times. Another category would be the changes to the language itself. The language now gives first-class support to some common usages and patterns. For example, now Scala has its own enum data type, which is much more powerful than its Java counterpart because it allows for parameterized cases, and by doing so, it can model even enumerations with infinite set of values. And there are a lot of smaller changes and improvements, not to mention the new very powerful tools for metaprogramming. So now let's take a closer look. Okay, so as a warm-up, let's compare the different ways we can run our application. So on the left-hand side, you see code written in Scala 2. And on the right-hand side, you see its Scala 3 equivalent. So in Scala 2, you could create an object with a main method that takes an array of string arguments. And you could also use the upgrade, which basically hides this main method. So whatever is the body of this object is basically the body of the main method. And these are, of course, just regular objects, so you could create another application that just calls the main methods of these objects. Now, in Scala 3, the first thing to notice is that you don't need the objects anymore. You can turn any statically available method into a main method by just using this @main annotation. And notice also here that we are not using an array of string, but instead a var of string. And also, if the method itself doesn't need any parameters, you can just skip it. So we also get parsing of primitive data types for free, like Boolean and int in this case. If I run this with these arguments that are parsable to Boolean and int, false and 7, and then followed by some strings, this would perfectly run without problems. And of course, these are just regular functions, so we can also create another application that just delegates to these. Okay,
Piotr,
now let's have a look.
Could I interrupt you for a second? People are telling me on Joy channel that they have trouble seeing your code because maybe it's a light mode or something like that. Could you make it maybe a bit bigger or turn into
let's try to make
dark
it
mode?
bigger.
Thanks a lot.
Yeah. So maybe that will work, hopefully. Okay, so also, for the automatic parsing, it can be extended to any type. So in Scala 3, all we have to do is just to give an instance of this from string type class to the compiler and have it available in the scope. And then we can just simply use this, our custom type as an argument to this main method. And this will also compile without error, and it will run without error. Okay, now let's have a look at the second example. Okay, so in this example, we will have a look at error handling. So we deal with errors every day, and practically every input has to be somehow validated. Whether it's parsing or looking up a record in a database, we have to deal with failure paths. So what we usually do is to encode these into values and delegate the handling of the error to the caller. So here we have an example of some domain-specific errors and some functions that return either the value that they compute or the error if they fail. And then we have a program that combines these functions into our program. But now over here there is a problem, because we know that when we try to match on the error channel here and add a handler to this program, we know that the only ways that this program can fail is, in this case, non-numeric input and division by 0. But the Scala compiler doesn't know this. The Scala compiler will actually infer here the lowest common supertype of those types, which is the domain error. So it will throw a warning at us. And one of the ways that we could just make this warning go away would be to add this catch-all case here. But this introduces another problem, because if somewhere in the future someone were to extend this program and actually introduce a case where this negative input error might arise, and then forgot updating this handler, then the compiler will not tell us anything about this. It will not warn us about the situation. Okay, so let's have a look at how that looks in Scala 3. So in Scala 3, we could use, instead of either, a custom data type, which I named here or, which is basically an either, but with a little change, which I'll explain later. So we have an equivalent program here. And if you look at the infer type, what it says is it's this union type of non-numeric input or division by 0 in the error case, which means, and which you could read also as non-numeric input or division by 0. And here, the compiler is perfectly aware that these are the only two cases that can happen in the event that the program fails. And what is even more nice about it, so if someone in the future were to introduce another case, and if I just save it and give the compiler a little time to work, yeah, we can see that it will now warn us that we have introduced another error case, which is not handled here. Okay. Now, so, and of course we can run this, and in this example, if we looked and maybe if we view the output, yeah. So in the Scala 2 example, it actually fails on the -5 case, which is not handled, this error here. While here we get the compilation error warning us about that. Okay, let's move on to the next example. And in the next example, I'll be talking about business domain modeling. So when modeling our business domain, we want to create new types to be able to constrain our code such that one cannot accidentally pass invalid values. And one way of doing that is to wrap our types in case classes. And often the base types are too forgiving. So to prevent the creation of invalid values, we make the final class, we make the class final, and we mark the constructor as private, while at the same time we're providing the so-called smart constructors in the companion object to be able to construct these values. And yeah, so we can run it. And so using these, there is one problem. Using the case class gives us the nice equals and hashcode methods for free. However, this will also auto-generate and apply and copy methods, which will be in this case public. And using this, just like I show here, you could get around the smart constructor and create invalid values. So there is a fix for that in Scala 2. So actually, you could also introduce this abstract modifier here. And in this case, the copy and apply method will not be auto-generated. However, there are some valid cases where you might actually want to use this copy method. So now let's have a look at how that situation changes in Scala 3. And well, in Scala 3, the way they solve this is the copy and apply method will be auto-generated, but they will have the same visibility modifier as the primary constructor. So in this case, in the companion object, we can actually use this apply method and the copy method, but we cannot use them outside of the companion object. Okay, now let's say we have an application and we are following the event sourcing pattern. So we might have some domain-specific types like email and user ID defined. And we also may have a bunch of commands and events defined. And yeah, and this is very verbose on the left-hand side. Let's see how that compares to its Scala 3 equivalent. So first thing to notice here, in Scala 3, we could just use opaque types. So these are just type aliases that are backed by other types underneath, which hide the information from the compiler about the underlying type. And this way, we don't have any runtime performance issues, like in the example on the left-hand side. And so outside of this companion object to email, the compiler is not allowed to know anything about this email type. It's just some type. But inside of this object, the compiler is perfectly aware that this email type is the same thing as string. So in this from string function, where we expect an option of email, we can just return this v value, which is a string. And also, we could express the same data structure for user command and user event using enums. And what you notice here is how much less verbose is the new syntax. These are the equivalent definitions, and there's just less typing here. Okay, so now let's move on to the next example. Okay, so let's say we wanted to build a DSL to build some HTML code snippets. And on the use side, we would like it to resemble HTML as closely as possible. So in Scala 2, you could encode that by creating an HTML data structure. And so it has a label, and then it also can take some nested child elements inside of it, and also has some function to render itself. So in general, it is a good idea to represent such things as structures as they can be inspected and transformed. But in this case, all we care about is the final HTML string. So let's just assume this is our only goal here. So, and and we could also have these specialized cases. So for some elements like P or B, we could define case classes that extend this trait HTML. And of course, for our text nodes, we would have to have overridden the rendering method, because the text nodes, they don't start with any opening or closing tags. They're just, the text is not wrapped in anything. And we could also have this function that starts this DSL context. So it's building this implicit string builder that we use to construct the final string, and it starts the recursive rendering of this whole structure. And finally, we have some implicit conversion from a string to our DSL, because we want to be able to use string literals just like that. Okay, now what Scala 3 gives us here is it introduces context functions. So now we can have regular functions just like this one, that with this question mark arrow operator, what we do is we tell the compiler that the preceding parameter list, we want it to be implicit. And now with this, we can basically implement the same logic, but we don't have to use these objects anymore. We can just have regular functions. So this would be this rendering logic here, similar like here. And then we would have defined some functions for some methods for our elements, so for P, B, H1, and div, delegating to this element method. And then we would also have this HTML method, which kind of starts our whole DSL context. And similarly, it also initiates implicit string builder. And also in this case, it starts the first indentation level sets as 1. Okay, and then similarly, we have a conversion. And now this is interesting. In Scala 3, implicit conversion are now expressed as a type class, this type class conversion. So wherever you have in scope an instance of this type class for some 2 types, you're basically telling the compiler, this is how you turn a string into an HTML. And this serves the same purpose as here, such that we can use these string literals directly. Okay. Now, what I think would be nice to have here is also if we could somehow have this varargs also expressed on type level, such that we didn't even have to use methods. We could just have simple values. But yeah, this doesn't compile. So this is one superpower that methods still have over plain functions. Okay. And yeah, and we could extend this example a little bit. So we could also define some more specific type aliases, like over here for each element. And in here, we are adding this type constraint to this alias. So since these are opaque types, the compiler is not allowed to know anything about them outside of their companion object context. But by adding this type constraint, we actually leak some of that information to the compiler. So the compiler does not know that P is exactly HTML type, but it does know that it has to be a subtype of HTML, and therefore we can use this type P, B, etc. In every place where we would require an HTML. And this, using the union types, also allows us to add additional constraints. So, for example, for P elements, we can require that only text and B elements can be its children. Okay, now let's move on to the fifth example. Yeah. Okay, so sometimes we have to use some external library or code that we have no control over. But we would like to be able to extend the available API. So in Scala 2, we had the so-called pimpmy library pattern for that. And in short, when we called a non-existing method, like this kilometer method is not defined for an integer, then the compiler would look for an implicit conversion into some other type that does have a matching method. And if it finds such a conversion and it's a unique hit, so there is only, there's no ambiguity, it will happily compile and perform the conversion silently for us. So to encode this in Scala 2, we would have to create this other type, so this wrapper class, and it would just take one single argument of the type that we're extending, and then in the body we would define all of the methods that we want to extend it with. And this would be also accompanied by an implicit conversion that does this automatic wrapping for us. And this pattern was so popular that at some point it received special handling. So this is when this implicit class syntax was born, which is basically this implicit class is this wrapper class and this implicit conversion done in one go. Okay, now let's have a look at what Scala 3 has to offer in this regard. So in Scala 3, what we are getting is this new keyword called extension. And if I align this right, you will see that basically this is the so-called extension method. And this extension method is extending the type double in this case. So we can see this is kind of a one-to-one correspondence. However, what I wanted to also show you here, that we also get this nice target name annotation Scala 3. So we can also create aliases very easily, not so verbose as in here. And what is also nice is that this actually in Scala 2, we never cared how this double ops class, what was its name. We never needed that because the creation of this wrapper object was always done implicitly for us. So in Scala 3, we don't have to name that. We just define that there is an extension for the type double, and that's it. Okay, and there is a little difference also on the use side. So in Scala 2, for this to work, we would have to have this implicit class in scope, so the implicit conversion in the wrapper object. And we import it to make it visible in this scope. However, we have no control over how much we're importing. We're importing all of this at once. While in Scala 3, if we have this extension method defined, we can import each of these by name, and we can even rename, just like with regular imports, using this arrow, we can rename one symbol to some other. Okay, now I see I'm running out of time, so I'll just quickly switch to the last example. So in the last example, I wanted to show also the encoding for type classes. And long story short, type classes allow us to take some common functionality and apply it to different types without changing their inheritance. And this is useful, for example, where we have no control over some data types. And the way we would define that in Scala 2 would be by having this trait that defines the functionality of the type class. We would also have this implicit class to have this nice dot syntax that we are using over here. And then we would also probably in the companion object have some default instances prepackaged. And we could also create our own instances. And I'll just quickly jump to Scala 3. So in Scala 3, what is nice is that the same thing, the same concept. So this dot syntax and the definition of the type class is actually reduced to just these two lines. So using extension methods, by adding this extension keyword, we can change this to be just able to call this with dot syntax. We can also prepackage the instances of the type class, and yeah, we can define our own, deriving the type classes from other instances. And one thing to note here, this is just a shorthand version. The full version would look like this. And I really like it because if you compare it with a regular method definition, it's just the same thing. So here we have a name of the method and some implicit parameters, and then finally the return type. And similarly, here we get some implicitly require some instances, and we return also have the return value ascribed in the same way. And so the definition above, I just don't care how this is named, so I can just skip that. And also I could name this if I wanted, like S1 and S2, but I don't have to. So as long as you remember this correspondence, it's easy to remember the syntax. Okay, so I need to wrap up. Yeah. So to summarize, I think Scala 3 is going to be awesome. The language is much more expressive. It provides us with more tools to encode our intent and has better type inference. The syntax is much more concise and less noisy with carefully chosen keywords. It is simply more clear and readable. And finally, many useful and common patterns have now received first-class language support. And you may think like these things, that's not such a big deal. In the end, we get used to the syntax, but I really believe that this will have a huge positive impact in the long run on our everyday work as developers. And this will lower the entry barrier for new faces in the community, and it will make it easier to use these tools. Okay. So if you want to get in touch with me, I'm tweeting at @ioleo. I'm also sometimes logging at Scala blog. You can also chat with me by visiting the Zio Discord. And if you want to dive deeper on Scala 3, I'm coaching Scala 3 workshops organized by Scala and licensed by Zarvec. And the next one will be on the 25th, 26th February. And it should be announced on Eventbrite on Monday, if I'm correct. So that's all I had. Thank you very much for listening, and have a nice day.